Because we live our life by consumption. What remains from our daily lives are nothing but waste, be it garbage or the source of wastewater. Won't it be better if there is a simple method for us to decrease this pollution by ourselves? The King's royally initiated Laem Environmental Research and Development Project had been constantly researched for this answer until they found that there was an economic way to manage this waste and wastewater pollution. A simple method that requires no complicated technology to turn wastewater into clean water, from organic waste to compost, which rich in nutrients. By relying on the method of nature by nature initiated by His Majesty King Bhumibol Adulyadej to be the treasure of our nation. We might know that His Majesty was never conformed to textbooks. But not conformed does not mean disregarding them. Secondly, it must be simple and easily applied by everyone. But inside, it must be built upon many scientific mechanisms. It took 2 to 3 years to establish this place and to completely equip it. Once everything is success, His Majesty came. I report the work which His Majesty assigned me in 1990 for him to see and discussed it to him. He said, "We had come this far now, let's share it with the people." He must have thought about a Buddhist proverb. Don't give the poor the fish, give them the fishing rod for them to fish. It's just like that. I must realize that first before I can accomplish anything. Once you have the knowledge, you can find your own way. The project conducts research to find the appropriate technology for treating wastewater and disposing of organic waste. By relying on the method, nature by nature, that requires no machine or complicated technology. Here, it's all about decomposing organic substances to inorganic substances by bacteria, which are microorganisms that can function under various conditions. We can classify microorganisms by their need for oxygen. The first type we call aerobic bacteria. They are bacteria that use oxygen in the decomposing process, just like how we need to breathe to generate power within our cells and have the energy to do many things. The next type, the second type, we call facultative bacteria. Some people said this group can either use or not use oxygen. But in depth, facultative bacteria use oxygen in the form of oxide, which is a compound of many chemical substances. For example, nitrate, which consists of oxygen. The last type is anaerobic bacteria. This type uses carbon dioxide to generate energy. But the result of the decomposing process by anaerobic bacteria is not what we need. Because the product from the decomposing process that does not use oxygen is gas with an undesirable odor, like methane and rotten egg gas, or what we know as hydrogen sulfide. For the wastewater treatment method, the LERD project has studied the method that will treat wastewater into clean water by using various kinds of natural technology. The project receives wastewater from Phetchaburi municipality, pumped through underground wastewater pipe from Ban Klong Yang wastewater station, 18.5 kilometers away. The water quality using BOD as indicators. We found that BOD is decreasing from the origin at Ban Klong Yang station to the terminal at the project. When we collect wastewater from each household, wastewater will drain into closed pipes. Is the wastewater treated from the beginning? Yes, it is. When the pipes are closed, the air cannot get in. And anaerobic bacteria will start to treat the organic substances. With such concentration, the organic substances will be turned into gas. Therefore, pipes that collect wastewater must have ventilation to release the gas here and there. When they arrive in Ban Klong Yang, which has an opening treatment pond that uses oxygen to treat wastewater, the aerobic and facultative bacteria will start working. After that, the wastewater is pumped for 18.5 kilometers from Ban Klong Yang to our project. This would take 5 hours and a half. During these 5.5 hours, anaerobic bacteria will be at work. Once the wastewater arrives here, each different system will be used to treat it. The wastewater from the pipe will be treated at treatment system by different technologies, which are oxidation ponds and aquatic plants wastewater treatment system. For wastewater treatment system that is oxidation ponds, it is a high-efficiency treatment system. Water will be stored in each pond for 7 days. These are 5 ponds, classified by their functions. The first one is the sedimentation pond. It is deeper than other ponds, so suspended solids or anything that has specific gravity than water will sink to the bottom. The water from the first pond will flow to the second, third, and fourth ponds, which are oxidation ponds, the main ponds in treating wastewater with biological method. The ponds are designed to increase the amount of oxygen by photosynthesis and thermosiphon process and let the treated water overflow to the next pond. This will help the aerobic bacteria work at maximum efficiency. Naturally, in a wastewater treatment pond, one of the sources of oxygen is oxygen from the air. We already have the wind in our nature. It's already there. The wind can help us add oxygen to the water. Another important process is photosynthesis by plants. These plants are phytoplanktons that grow within the pond. They turn energy from sunlight to chemical energy that are stored within the cells. The result of photosynthesis process is oxygen. The oxygen produced by phytoplanktons through the photosynthesis process will dissolve into the water, and the bacteria in the water will use it to digest organic substances. Another method is thermosiphon. Because the water surface will occur evaporating during the day, the water at the surface will become cooler. One characteristic of the water is that it weighs more when it cools, and so it will sink to the bottom. When the oxygen is brought down like this, the densely oxygen from the wind blow on the water surface can sink to the bottom of the pond. And this will give the bacteria more oxygen to work with. When bacteria use oxygen in the digestion process, the product we get is compound matters such as phosphate and nitrate, which can become food for microalgae and phytoplanktons to grow. If we do not keep the number of microalgae and phytoplanktons under control, it will be threat to the treatment process. Thus, the LERD project has researched how to control phytoplankton and cyanobacteria by feeding herbivore fish. Our research found that the appropriate ratio of herbivore fish that we should have is 4 fish per 1 square meter of the water surface. The fish we feed are Nile tilapia, rohu, and silver barb, for example. Once we feed these herbivore fish, we will take them out after they are fully grown. The age of the fish that we use to control the number of phytoplanktons starts from when they are 2 inches long. Every 6 months, we will use a 10mm fishing net to catch all the big fish and leave only the small fish to control the amount of phytoplanktons and to maintain the balanced amount of phytoplanktons for continuing photosynthesis process. From the 4th pond, the treated water will flow into the 5th pond, which is the stabilization pond. This pond is more shallow than others because we need radiation from sunlight to kill any pathogens in the water. This is the last treatment before releasing the water into nature. The aquatic plants wastewater treatment systems which the project studied were aquatic plants and grass filtration system, constructed wetland system, and mangrove forest filtration system. The aquatic plants and grass filtration system and the constructed wetland system has a structure to grow plants, soil pact and plant selection, and a management plan that oversees the process from planting to harvesting, so it supports to the biodegradation process, which will add oxygen to the system via thermal osmosis process, which involves two bacteria within the soil, in the wastewater, and the ecosystem around the plant's roots, and most importantly, the cells of young leaves. Our research found that the plants in our system possesses the ability to transport oxygen via their tissue and release it around their roots. The tissue that has the ability to transport air is parenchyma tissue that lines up loosely. Leaves whose tissues line up loosely are young leaves. Their photosynthesis process will leave some oxygen behind, or what we call excessive oxygen. This oxygen will be released around the root of the plant like an air pump that will add air to the soil. Bacteria that lives around these plant roots or rhizosphere bacteria will use the oxygen released from the roots to generate energy for the aerobic digestion process. After that, plants in the system will absorb nutrients for their growth and create different kinds of tissue like stems, leaves, and flowers. Thus, we need to cut them so the new rhizomes could grow. New leaf tissues line up loosely, and this allows very effective oxygen transportation to the rhizosphere, or what we call thermal osmosis process, to happen with high efficiency. Another technology to treat wastewater is the mangrove forest filtration that relies on the absorption of nitrate or phosphate, which are inorganic substances resulted from the digestion of bacteria, and use them to grow while also diluting wastewater with seawater during the high tide at a 1:1 ratio, which will help to treat wastewater. The results from various kinds of the treatment system in the LERD project, when measured by BOD parameter, is found to be under the domestic wastewater standard by the Pollution Control Department. The solid waste which humans create in our daily life generally 65% of it is organic waste, which can degrade naturally. The King's royally initiated Laem Environment Research and Development Project has studied and developed a technology to dispose of domestic garbage, especially organic waste, by turning them into compost, by applying the method of sanitary landfilling and composting them in a concrete box, so we can avoid using a lot of space, a lot of money, and so it will be easier to use the fertilizer from the process. We will put organic waste into a concrete box, then separate each layer with paddy soil to assist efficiency of the bacteria digestion process. We spread water on the top layer to add moisture and oxygen, which will help the digestion process within the box, creating more heat, which is good for bacteria that work at high temperatures. The temperature of the organic waste will go up step by step. It will increase slowly. At a certain point, it will be stable. After that, it will continue to decrease. We also conduct research at each temperature and found that organic waste consists of carbohydrate, protein, fat, and fiber. Once the temperature in concrete box increases from above 50 to 70, the thermophilic bacteria will dominate and grow. These bacteria are such as actinomyces, fungus, or certain kind of bacteria. They have a certain quality that will produce specific enzyme to digest fiber and cellulose and support the digestion process, make it more efficient when the temperature in concrete box is high. The digestion process will occur gradually and will take around 30 days or 1 month to complete. We will get compost that is rich in nutrients. However, the LERD project also found that during the digestion process, the factor that affects the quality of the compost is the carbon to nitrogen ratio. Bacteria's growth and digestion require carbon and nitrogen as the inhibitors in the system. These two exist in relation and can indicate whether we will get the fertilizer. The C/N ratio or carbon to nitrogen ratio must lower 20 to 1, must not exceed this so we can get a standard compost. In the beginning, the appropriate C/N ratio is around 30 to 40 to 1. An unbalanced number will become a problem. When bacteria start digesting organic compounds, they will use carbon. If we have things like rice straw that are hard to digest, we will get a lot of carbon. When we have a lot of carbon, the bacteria will start using carbon and we will run out of nitrogen. The bacteria will use nitrogen from their surrounding, which is the soil. That leads to nitrogen deficiency in the soil, and it will slow down the digestion process. Thus, we need to keep the C/N ratio in balance. If we have rice, we add rice. If we have meat, we use it as protein. If we have plants, then put in those plants too. When we have a variety of organic compounds or things we compost, it will also affect the nutrients in the fertilizer. We will have more nutrients and diverse nutrients: nitrogen, phosphorus, potassium, calcium, or magnesium. These secondary elements will increase. The project has publicized this knowledge and method to treat wastewater and dispose of domestic waste, and the project supports a variety use of it, be it on the individual level, community level, organization level, or institution level. The LERD project area are suitable for the development of environmental science. The King's Royally Initiated Laem Environment Research and Development Project has established an international learning center to provide academic service, research, and action in environmental development, and to provide training in environmental science, both in Thai and English, to benefit interested citizens, such as students, researchers, both Thai and international. Throughout the 70 years of his reign, His Majesty gave his all to develop the land. One might say he cares for the land, not ruling the land. He used it no power, only mercy and love that protected the land. Why would he try to preserve the land? It's for his people. Never forget, 70 million of us here. Every breath comes from the land. Every meal comes from the land. The clothes, the basic necessity, all from the land. And one day we destroyed it. Fights for resources happened all over the world, not just in our country. His Majesty gave his all to find a way to preserve what was left, revive the forest, revive the water, the polluted wastewater. How can we make use of them? Now we have enough lessons. What is left is moral compass and action. Not for His Majesty or for anyone, but for our own survival. And more than anything, for the land we will pass on to our children, for it to be where they shall find happiness. That's how one carries out their responsibility as a human, and fulfill one's responsibility as a Thai. The victory of this country belongs to Chai Patana Foundation. It's a peace and as an advanced country until we become the champion of development. The origin of the name Chai Patana Foundation, Chai, victory of Patana, development, has the goals of peace, prosperity, and abundant life. The royal words by His Majesty, King Bhumibol Adulyadej, December the 4th, 1994.